So we know that if you have the table for the y equals 2 to the x function, you can turn the columns around, you get the change, you get the table for the inverse function, which is a log base 2 function. Now, if you think about what the table is telling you, since you switched the columns, in handling this board, I kind of erased that line. Okay, top line here says that y equals log base 2 of x, which would be this, so here are your columns, is equivalent to x equals 2 raised to the y. So if here's your y and here's your x for the log base 2 function, well, where's the 2 going to go and where's the 4 going to go? 2 is going to go for the x and the 4 is going to be your y, right? So switching the roles of x and y, and that gives you the 2 to the x function. Well, if you think about what that means, it tells you that y equals log base 2 of x would mean like 2 is log base 2 of 4, okay? And x equals 2 to the y says that x is 2 and y is 4, right? Okay. So, anyhow, there we have it. I think I said that wrong, but I think you get the idea. Also, y equals 2 to the x is equivalent to x equals log base 2 of y. Okay? And log base 2 of 2 to the x equals x. We did that last time. You got 5 here and 2, you got 2 to the 5th here. So you're going to have 2 to the 5th here, you're going to have 5 here. Okay? So the 2 to the 5 is this. And then you plug 2 to the 5th into the log base 2x, and you get 5 back. We traced that last time, so kind of review what we did last time. Okay, well, we're going to use those to solve equations. So we want to solve the equation 2 raised to the t minus 3 equals 4. Okay? Well, we use the fact that y equals 2 to the x is equivalent to x equals log base 2 of y. Now this is like y equals, this is y, this is 2 to the x. Okay? So this is like 2 to the x equals y for x equals t minus 4. And 2 to the x equals y is equivalent to y equals log base 2 of x. I think I said that wrong. Okay, this is equivalent to x equals log base 2 of y. Okay? That's like 2 to the x equals y, so x is log base 2 of y. Just the reversal. You got to kind of get used to those equivalencies. Once you are, it's easy. Because all you do now, but now x is t minus 4. Need to identify everything again. This is 2 to the x equals y for x equals t minus 4, because that's the power of 2, and y equals 3. Okay? So, t minus 4 is log base 2 of y, which is log base 2 of 3. So, we can just rearrange. And we get t minus 4 equals log base 2 of 3, and that's easy to solve for t. Like, what step do you take to solve this for t?
Add 4 to the other side.
Add 4 to both sides. No, not the other side. You add it to both sides. Okay? So, anyhow, you do that, you get 4 plus log base 2 of 3, and you go to your calculator and get log base 2 of 3. Remember how to do that? Log of 3 over log of 2. Okay? So if you understand these equivalences, you can do this. Okay? The other thing you can do, the alternative way of doing this, is you do the log base 2 of both sides. Okay? Log base 2 is inverse to the 2 to the x function, right? So the log base 2 of 2 to the t minus 4 is just t minus 4. For the same reason that if you start here and get this number and then put this number into this one, you get back to the number you started with. It's the inverse function property. Okay, it's f inverse of f of t, or f of t minus 4, or whatever. So this just tells us that the log base 2, I don't like to use words, so I won't. Log base 2 undoes the 2 to the x function, okay? Giving you just whatever is in the exponent. So you get t minus 4 equals log base 2 of 3. And that's identical to what you got here just by doing the rearrangement. Okay? So let's do the same thing with this one. See if you can write it out. Just imitate the steps if necessary, whether you totally understand where it comes from or not. Just get used to the idea and the sequence of things you need to write down.